convey kind of the best estimate, and then we've got some gray lines that are meant to convey uncertainty. In this case, the uncertainty is defined by different emission scenarios that were used in the projections provided by the national academies. There's a variety of different approaches towards uncertainty. That's the one that we chose for this particular project, but it's important to note that there's a variety of directions that you could go with dealing with uncertainty. You just have to be prepared to sort of communicate and justify them. We then pulled out 3 what we called map scenarios. These were simply elevations relative to the current mean higher high water shoreline. That was our sort of project shoreline. That represents kind of the modern day kind of upper beach. And we mapped each of these elevations relative to the current mean higher high water shoreline. We also wanted to represent, I'm going to show you one of those maps in just a second, but we also wanted to represent these other processes that drive water level intermittently higher that could be combined with sea level rise to have impacts above the mean higher high water shoreline. In the Pacific Northwest, obviously this is sort of storm surge that's a major factor in other parts of the country. In the Pacific Northwest, based on the available historical information, our sort of upper levels of storm surge, our extreme probabilities of storm surge, are only on the order of 3 to 3.2 feet or so. So we're very fortunate in that regard in comparison to lots of places that are exposed to hurricanes, for example. For this particular project, we chose to map a 50-year return interval storm surge to try to express on the map sort of locations that may be intermittently impacted by kind of a worst-case storm scenario when it's coupled with sea level rise. So an example map is shown here.